Hi guys, so our next lesson is all about stoichiometry or laboratory mathematics. Now, in practical applications, you're not really going to be able to use stoichiometry for your laboratory practices, but it's very much useful to develop critical thinking skills and the processing of your experiments. So, let's start. First, let's define what dimensional analysis is. Now, dimensional analysis is a general problem-solving method in which the units associated with numbers are used as a guide in setting up calculations. So basically, when you say dimensional analysis, you're tackling computations from different points of view or simply converting one unit to another. Uh, some computations require that you use uniform units. For example, if you're computing for milliliters, you're not going to be able to, or you're not going to be able to compute using ounces or other units of measurement for volume. So it's best that you know how to compute or how to convert from one unit to another so that you can perform the analysis well. Now, as an example for dimensional analysis, here is a simplified set of examples rather. So you're going to see here 5 times 5 is also equal to 5 squared. So how did this become dimensional analysis? So you're basically equating 5 and 5 with 5 squared, which means that you can use either of the two units for a simpler and much more streamlined computation, unlike when you have to expand it to 5 times 5. Next is centimeters times centimeters is equal to centimeters squared. Now, this is also another form of dimensional analysis that directly relates to your first example, 5 times 5. And then, of course, when you're trying to compute for, when you're dividing two similar terms, all you'd have to do is cancel out the similar terms. Okay, so basically, it's making computations a lot simpler and making computations more streamlined. And by doing dimensional analysis or by using dimensional analysis, you're actually making your computations a lot more accurate and a lot more streamlined. Now, we have steps to follow in performing dimensional analysis. To be specific, we have three steps to follow. Now, these steps are simply guidelines and not actual rules. So this is just to make your life or make your computations easier, other than actually um, set the standards for dimensional analysis. Number one is to identify the known, excuse me, or given quantity and the units of the new quantity to be determined. Write an equation with the given quantity on the left and the units of the desired quantity on the right. So basically what you're going to do is you're going to identify the known or given and then what you want to convert it to. So for example, you have centimeters and you want to convert this to meters, so you're going to write this on the left side of your equal sign and then you want to convert it to meters, so all you have to do is write it down as such. So identify the known or given quantity and identify the unit that you want to convert it to. In this case, our known quantity is centimeters, and then our new unit is meters. So centimeter should be written on the left side of the equal sign, while meter should be written on the right side of the equal sign. So basically, yung given quantity ilalagay natin sa left side, and then yung gusto nating makuhang quantity or na measurement ilalagay natin sa right side. Next, multiply the given quantity by one or more conversion factors in such a manner that the unwanted or the original units are cancelled, leaving only the desired units. So let's talk about conversion factors. When you say conversion factors, these are equivalents of units. So for example, you have 1 centimeter is equal to how many meters? 0. Baguhin na lang natin. No? Medyo nakalimutan ko na. So, anyways, let's try a much more common example. Let's say 1 kilometer is equal to how many meters? So that's 1,000 meters. So basically, this is what you call or what is known as a conversion factor. So sinasabi natin dito that 1 kilometer is equivalent to 1,000 meters. So paano natin ilalagay or paano natin siya isa-set up so that we can cancel out our original unit. So sabihin natin you have 2 kilometers and then you want to convert it to meters. Okay, so basically sinunod natin yung step 1, what is given nasa left side and then yung desired unit natin nasa right side. So paano natin maka-cancel out to? So simply multiply 2 kilometers with your given conversion factor in such a manner, sabi sa step 2, that the original unit is cancelled out. So times, sabi multiply daw, and then gawa tayo ng conversion factor. So ilang meters daw? 1,000. Yan. So sorry, medyo mabagal magsulat dahil naka-trackpad lang ako. And then 1,000 meters. And then para ma-cancel out natin si kilometers, dapat yung 1 kilometer na conversion factor niya nasa ilalim. Okay? So simply cancel out. And then in this case, you're left with 2 times 1,000 meters. Ang sagot natin dyan is 2,000 meters. Okay? So that is just the basis of your dimensional analysis, converting one unit to another. Now, step 3, I believe, is performed mathematical operations indicated by the conversion factor setup. So, nagawa na natin yun sa last slide. Ginawa lang natin is minultiply natin si 2 kilometers to a conversion factor of 1,000 meters over 1 kilometer. So, saan po natin kinuha yung 1,000 meters over 1 kilometer? Again, that is the conversion factor ng ating kilometers to meters. Saan natin kukunin yung mga conversion factors? Siyempre, doon po sa table of prefixes natin na diniscuss nung prelim period natin. So, di ba, nag-discuss tayo ng prelim period, table of prefixes, nandun yung conversion factor ng kilometers to meters. Okay? So, just perform the mathematical equations and then box your final answer. Now, just for uniformity, no, I know since wala tayong paper or wala tayong pen or paper, if ever you have assignments concerning dimensional analysis na kailangan mag-manual compute sa paper, excuse me, mag-dimensional analysis tayo, yung final answer natin dapat laging naka-box para madaling i-check. Okay, so again, perform the mathematical equations. Now, okay, paano naman natin siya i-apply sa analytical chemistry? Now, for example, a standard aspirin tablet contains 324 milligrams of aspirin. How many grams of aspirin are in a standard aspirin tablet? So, first of all is we have to identify the given. Meron tayong 324 milligrams, and then gusto daw natin siyang malaman kung ilang grams ang meron. So, tulad ng sabi natin kanina, step 1, kung titignan natin nasa left side ang ating nasa left side ang ating given, and then sa right side naman yung hinahanap natin. So, you're given 324 milligrams, sinulat yan sa left side, and then you're given, or rather, you want to convert it to grams, so sinulat natin siya sa right side. Now, step 2, use of conversion factor. Hanapin natin yung conversion factor. Ilang milligrams pa ang meron sa isang gram? So, tignan natin. 1 milligram is equivalent to 0.001 gram or 0.001 gram is equivalent to 1 milligram. Now, sir, ano po dito sa dalawa ang gagamitin namin? That depends on how you have to set it up. Since milligrams po ang kailangan nating ma-cancel out, kukunin natin dito sa dalawa yung conversion factor na nasa ilalim yung milligrams. In this case, 0.001 grams sa taas and then 1 gram sa ilalim. Again, bakit po ito yung kinuha nating conversion factor? Kasi we have to cancel out milligrams doon sa original value natin para mapalitan siya ng grams. So, ito yung gagamitin natin. Okay, so check natin. Okay, so 324 milligrams times the conversion factor 0.001 gram over 1 milligram. Nakikita naman natin, naka-cross out na si milligram para ma-indicate na na-cancel out na siya. And then all we have to do next is multiply 324 with 0.001. In this case, ang sagot po natin is 0.324 gram. Okay? So dimensional analysis is a complicated it's a complicated system when you look at it from a difficult point of view, no? But if you follow it step by step, you'll find na madali lang talaga yung stoichiometry natin. Kasi common misconception ng mga students natin or ng lahat ng taos, ano ba yan, stoichiometry, computation na naman, mahirap, mahaba yung process. But then if you look at it in a step-by-step process, mas madali lang siyang i-perform, madali lang siyang gawin. Okay? Next, let's define a few terms bago tayo magkaroon ng or bago tayo mag-move on sa ating mga conversion factors na gagamitin sa ating stoichiometry. Kapag sinabi nating atomic mass, that is the mass of atoms of elements expressed in AMU. So, kapag ang hinahanap natin dito ay elements, oxygen, carbon, argon, nitrogen. So, kapag single element lang ang pinag-uusapan natin, ang weight nila is called atomic mass. Kapag naman sinabi nating molecular weight, this is the sum of the atomic masses or the atomic weights for the atoms in a molecule. So kapag magkakasama na siya sa isang molecule, molecular weight na ang tawag sa kanya. It's no longer atomic mass. Again, kapag mag-isa lang, atomic mass. Kapag may kasama na siyang iba, molecular weight na yan. Okay, so for example, the molecule ethane, C2H6, yung molecular weight niya should be C2. Since dalawa po yung C natin dito, C2 nga siya, i-multiply niya yun dun sa atomic mass ng carbon, which is 12. So 2 times 12, this is 24, plus H6. Si H, ang atomic mass niya is only 1. So even if you multiply 6 times 1, 6 lang din yung makukuha mo. So that would be 30. So kapag tinanong kayo, ano yung molecular weight ng ethane, answer is 30 AMU. Okay? Next, the mole. The mole is, excuse me, the SI unit for the amount of substance, and it is defined as the amount of substance that contains the same number of entities as there are atoms in exactly 12 grams of carbon-12. Now, medyo technical yung definition, but just remember, a mole is equivalent to 6.02 times 10 raised to the power of 23 objects. Atoms or molecules, no? So, these are particles. So, kapag sinabi nating mole, it's one unit of the element. So, kapag mole, lagi natin tatandaan si 6.02 times 23. This is also known as your Avogadro's number or constant. Okay, so 1 mole is equivalent to 6.02 times 10 raised to the power of 23 objects. Now, tandaan nyo guys, kapag may nakita na kayong equal sign or kapag may nakita na kayo dito na conversion factor, that is automatically convertible to your fractions. So, kapag may equal sign na ganyan, pwede nyo siyang i-convert na ganito. Okay? Sample problem, how many aspirin molecules are there in 0.23 moles of the same substance? Now, let's see, let's first define the given. No? So, 0.23 mole of the same substance daw, and then tinatanong, how many aspirin molecules? Answer is 1.4 times 10 raised to the power of 23 aspirin molecules. Now, paano natin nakuha yan? You have 0.23 moles of the same substance. So, kinuha lang natin 0.23, sorry, times, or rather, lagay natin yung unit, mole, times, kunin natin yung conversion factor. Siyempre, ilalagay natin si 1 mole dito sa ilalim. And then, ilalagay natin yung Avogadro's number sa taas. 6.02 times 10 raised to the power of. By the way, guys, kapag nakita niyo itong big letter E, that is a notation for times 10. So, big letter E times 10 raised to the power of 23. Kapag minultiply natin yan, you're going to get 1.4 times 10 raised to the power of 23 aspirin molecules. Okay? Next sample problem, how many oxygen atoms are there in 1.6 moles of the same substance? Let's have the answer. 9.6 times 10 raised to the power of 23 oxygen atoms. Now, I'll leave the computation up to you, but it's basically the same, or rather, pareho lang po siya ng computation nung first sample problem natin. Okay, so try to compute on your own and see if you come up with the same answer. Next is what is known as molar mass. Now, the molar mass in grams of a substance that is numerically equal to the substance formula mass. So, for example, the compound CO2, formula mass of 44.01 AMU, kapag sinabi nating molar mass, that is the equivalent of 1 mole of, or rather yung mass ng isang mole ng molecule. Okay, so in this case, 1 mole of CO2 is equal to 44.01 grams of CO2. So basically, yung isang mole, instead of Avogadro's number natin siya kino-compare natin siya dun sa molar or sa atomic weight or sa molecular weight ng ating substance or ng compound. In this case, paano natin nakuha si 44.01? Siyempre, kinuha natin si 12, which is carbon, or yung atomic mass ng carbon. And then yung dalawang oxygen, which is 16 times 2, so 32. And you add them up, makakuha ka ng 44.01. Okay? Again, if you have the equal sign rendered, pwede mo na siyang i-convert into fractions. Okay, so baka ma-confuse kayo sa terms. Kapag sinabi nating atomic mass or atomic weight, ito po yung single element lang. Kapag sinabi nating molecular weight, that is the weight of the compound. So, kapag may kasama na siya, for example, H2O, may kasama na siya, tapos kinuha mo yung weight niya, you call that molecular weight. Kapag naman yung weight niya ay kinompare mo na sa isang mole ng substance, ito na ang tinatawag nating molar mass. So, since meron tayong 1 mole of CO2 dito, inequal natin to 44.01, you call this the molar mass. Okay? Next is a sample problem again. Calculate the mass in grams of a 0.30 mole sample of acetaminophen. Molecular formula CHON C8H9O2N. So tignan natin step by step. Sorry, wala na palang step by step dito. 45 grams na agad ng acetaminophen. Okay, chemical formulas and the mole concept. Let's continue this in part 2 of our lecture kasi medyo mahaba na yung part 1 natin. I try to make it a bit short para at least hindi rin mabigat when I upload the video and kapag pinanood nyo. Okay, so that's it for part 1 muna. Again, we'll continue this on part 2 of our stoichiometry. So for now, goodbye po muna and I'll see you on part 2.